Now we are looking at the tan chord theorem that states that the angle between the tangent to a circle and a chord are drawn at the point of contact is equal to the angle which the chord subtends in the alternate segment. So that simply tells us that the angle between the tangent and the chord, which is this angle, this is a tangent, this is a chord, it is equal to the angle subtended by the very same tangent, the very same chord where at the alternate segment, meaning that will be equal to this, right? Okay, so now, and then we also have angle subtended by the tangent and the chord, and then this chord, the angle subtended by the tangent and the chord, it's equal to the angle subtended by the very same chord at the alternate segment. So now we need to prove that. So now we can say we are required to prove that n angle jk, it is equal to angle L. Right, let's go through it. So now the first thing we're going to do, we're going to construction. We're going to draw a diameter. Draw diameter JOB and join BL. Okay, let's draw diameter JOB. Then we're going to draw a diameter. Right? Okay. Okay, so it means then our B, we're going to have our B to be, oops, let me remove the ruler. We're going to have our B here, that is JOB, that is diameter JOB, right? And then we have BL. Here is our L. Our L is here. Okay, so now we're going to have 1, 2, JL1, 2, and then we're going to have 1, 2. That is L1 and 2. Then by look of things, we can see that angle J1 plus angle J2, that gives us 90 degrees. Why? Because the tan, that's perpendicular to the radius, tan perpendicular to radius. So we have our tangent to be here, and then we have our radius to be here. So tan perpendicular to the radius, it forms an angle of a 90 degree. Okay, so we also have L1. Let's look at this. We have angle L1 plus angle L2 to be equal to 90 degrees. Then that we're talking about this angle here, angle L1 and angle 2, then that is the angle subtended by the diameter. The angle subtended by the diameter, it forms 90 degree. So you can say angle angles in semicircle, so they form 90 degree. So then going forward, now we can say, to make your life easy, let angle J1 to be equal to X. And then if J1 it is equal to X, and we know that J1 plus J2 it is equal to 90 degrees. So if we can take X to the other side, then we're going to have something of this nature, where J2 it will be equal to 90 minus X. Am I right? Then, okay, moving forward, we now have L1 and L2. So if we can look at angle, if we can look at angle L1 and L2, they are equal. Why are we saying they're equal? That forms a butterfly. So those two are equal. Let's look at it from GeoGebra. Let's take a look from it. Let's take a look. And we say we have something of this nature. We have something of this nature. And then let's look at the angles. You see, the angles are equal. So angles in same segment, they are equal. That is 42,9. So those two are equal. Then now we have L2 to be equal to that, and we know that L1, I mean J1, this is J, am I right? This is our J. J1 is equal to X. So this means this will be equal to X. And then also we'll have L2. We'll also have L2 to be equal to 90 minus X. Right, that will be 90 minus X. Because, why? We said previously, let me highlight it. We said J1, it is equal to L1. And that is equal to X. What is the reason? The reason will be angle in the same segment. Right. So now if we can look at this, we'll see that J2 and L2, they're equal. So angle J2, it is equal to angle L2, right? And then angle J2, that is what we call N angle JK, which is equal to angle L2, which is angle L. Then now you have proven that the angle subtended by the chord and the tangent is equal to the angle subtended by the chord, the very same chord at the alternate segment. Okay, let's take a look at it. Let's take a look. Let's say we have a circle, and then let's draw a tangent. We have a tangent, and then we're going to draw our shape. So, okay. Now, what are we going to do? We're going to measure the angle to check if the angle subtended by the tangent, the angle subtended by the tangent, and the angle subtended by the tangent and the chord, it is equal to the angle subtended by the very same chord at the alternate segment. Okay, so we have measured the first angle. I want to remove this. Okay, that is 44. Believe we can see it. That is 44. And then let's measure the angle at the alternate segment, and then going to measure this angle, that is 44,7. So that is tan chord theorem. That's subtended by the very same the angle subtended by the tangent and the chord. It's equal to the angle subtended by that by the chord at the alternate segment. Right? Let's take a look. Here we have 62. Then let's measure this also. That is also 62. So they are equal. So the theorem, it is valid. It is true that the angle subtended by the chord and the angle between the tangent and the chord, it is equal to the angle subtended by the very same chord at the alternate segment.